In this study, we work on a newly available dataset called China Government Employee Database (CHIN) in collaboration with experts in quantitative history to study career mobility in a historical context. We present our system CareerLens, an interactive visual analytics system for analyzing large-scale historical career mobility data. Our system has 5 major parts. The parameter view and distribution view are provided for data filtering. The group view and the person view are used for the social group and the influential person recommendation, and the career flow view is for a detailed analysis of career mobility. In this video, we demonstrate a case study to explore the political elites from South and East China. The experts first specify the population of interest in the parameter view by choosing career length, time period, and the background information. Then the statistics on job levels are shown on the distribution view. Since the proportion of destination job levels higher than 5 is relatively high compared with that of the whole elite population, the experts brush these officials with vertical movements for further inspection. The mobility rate timeline in the career flow view shows the promotion and demotion rates of the chosen officials over time. The promotion rate was initially unstable and became stable later. The demotion rate was at a low level with a slight rise around 1883. Considering the political unrest in the late 19th century, the expert wonders how the promotion officials differed from others. He can hover on a bar unit to use a glyph to compare the statistic features of promotion or demotion groups with the static group. In the glyph, different color areas represent different groups: yellow for promotion, black for demotion, and blue for static group. It is a modified radar chart with 4 features corresponding to 4 categorical attributes, namely birthplace, ethnicity, exam degree, and job department at the beginning of the current 3 years. For the promotion or demotion group, experts want to see whether an attribute value dominates this attribute and distinguishes this group from the static group. The glyph thus distills the attribute value with the largest proportion in an attribute in the promotion or demotion group and computes the proportion of the same attribute value in the static group for comparison. Let's go back to the case. The expert stops at one bar where the glyphs show that officials from Hunan were more likely to get promoted than steady ones, which might be related to a reform where many Hunan-born officials joined and got promoted. Then experts can inspect the career flow below through 2 modes, job level mode and department mode, using a switching button. 2 color schemes are applied in these 2 flows: red, brown, blue, and gray for job level, purple and green for department locations. The population distribution are consistent with previous conclusions. However, zooming for the detail, the expert is surprised by various types of flows that happen in a short time period. After having an overall inspection, the expert goes to the group view to study latent groups. The group view recommends the groups with different promotion patterns detected by a sequence mining algorithm. He chooses the first one with most officials, and the group is highlighted in the career flow as a subflow by default. We provide a novel flow design that adopts a multi-skill approach where the interested groups or individual social relationships are embedded. It consists of 3 layers of information, namely overall mobility flow, group subflow, and individual career thread. Here, most individuals are distributed in the middle region. Switching to the department mode, the expert finds most of them moved from the first 2 central departments to a county department, indicating a strong correlation between job level and department transferring in this group. Experts can further highlight several individuals with relative time mode and finds 2 officials obtaining higher positions also promoted faster than other group members. Switching to the department mode, the expert finds the 2 officials who get higher positions were finally called back to the central government, whereas the demoted one just wandered among other county departments. The expert explains sending officials to the counties is an existing while rare routine to have them better trained. They will be called if worked excellently. Also, they will be demoted if they fail to manage work well. To understand how the social relationships affect the official's career mobility, the expert can go to the person view and use filters to define the influential officials. The system also provides a sorting feature to easily identify interesting officials. Each horizontal bar shows an individual's job level information. The total length encodes the career length. It compares multiple small bars with length encoding corresponding working periods and color encoding different job levels. The expert quickly notices that the second official directly jumped from level 7 to level 2, indicating that he was a fast rising star. Such great promotion was rare in the chain bureaucracy. He chooses this official and the career path is highlighted as a thread in the career flow, with department glyphs overlaid. The experts can hover on the glyphs for detailed information. Different social relationships are provided in a drop-down menu. He can choose specific types such as colleagues and trainees to show these officials and inspect their social interactions with the influential official in the flow. Most of them ended up with high positions. The solid line segment means he worked together with the influential official, and the dashed line segment means they did not work together. Hovering on these threads to get more information, the expert verifies that most officials had strong social connections with this influential official. Thanks for watching.